Hi guys, this is a new YouTube channel and this is my first video. This channel is going to be mostly about tech and computer science concepts in general. So today I'm going to talk about a topic which is very common in courses like Theory of Computation, Automata Theory and Formal Languages, then Fundamental Theory of Computer Science and some similar names like that. So this topic is called as Minimization of DFA. So, as the name suggests, minimization of DFA is basically minimizing a DFA. So, what do you mean by minimizing? So, minimizing is basically reducing the number of states in that particular DFA. So, how can we reduce it? How can we reduce the number? We can reduce it when we can merge few states together. But how can we merge it? We can only merge it if we find some kind of common point or a similarity between two states. So to understand similarity and dissimilarity, we need to understand what algorithm we are talking about. So to minimize the DFA, there are various methods, but one of the method that we're going to talk about today is the table filling algorithm. It is also called as officially Myhill Nerode Theorem. So usually people don't call it by the Myhill Nerode Theorem name. It is usually known as table filling algorithm. So I'm going to show you that. Okay. So when we talked about similarity and dissimilarity, we need to know what it is about. So if you can see here, these terms are these are the terms that we're going to use in this video. So these terms are really important. Try to understand what this term is about. So what do you mean by distinguishable? So distinguishable means which we can differentiate. So that means one state should be different from the other. So if one state, if it's going to a final state and another state is going to a non-final state, that means they are distinguishable. And usually distinguishable states are denoted as 1. So in the table that we're going to fill, if these states are distinguishable, we denote them as 1. And indistinguishable is exactly opposite to it. If one state is going to final state and another state is also going to final state, then they are indistinguishable. Also, this applies if the one state, if it's going to a non-final state and the other state is also going to a non-final state, then also they're called as indistinguishable states. And these indistinguishable states are denoted as 0. Okay, so let's try to understand with an example. So this will be so you will be given a question like this, you will be given a DFA like this. And to make our life easier, we first draw the transition table. So as you guys know how to draw a transition table, we take all the states here and we take the inputs on this side. And as we can see, Q0 on A goes to Q1. So we write Q0 on A goes to Q1, Q0 on B goes to Q2. So Q0 on B goes to Q2. So in this way, this table is filled. So this is going to make our life easier when we start doing the table filling algorithm. Now let's go to the table. So usually the table is shown as a matrix here, and on the both, like in the column wise and row wise also, we take the same states. So here, first what we do is we try to fill the boxes only on one side of the table, either on the upper side or the bottom side. I'll show you how. So first, if there is Q0 and Q0, if it's going to the same state itself, we denote it as 0. In the same way, if Q1 goes to Q1, we denote it as 0. And then Q2 goes to Q2, then we denote it as 0. And Q3 goes to Q3. If it's a self loop, then we do it like this. In Q4 and Q4, we denote it with 0. Now, we know that Q2 and Q4 are final states. Here also, I'm going to do Q2 and Q4 as the final states. So if we mark it this way, it will make it easier for us to fill the table. So what we're going to do is we are going to check each and every column and in like row wise. So what we'll do is we'll try to see if Q0 and Q1, we'll try to compare Q0 Q1, then Q1 Q0 Q2, Q0 Q3, and then Q0 Q4. So the first thing that we need to do is we need to fill the boxes, and we fill the boxes which are distinguishable. That means one state should go to final state and one state should go to non-final state. So here Q0 and Q1. As we know, Q0 is a non-final state and Q1 is also a non-final state. So we don't fill anything in this box. Now Q0 and Q2. So we can see that Q0 is a non-final state and Q2 is a final state. So that means they are distinguishable. So what do we do in distinguishable? We mark it as 1. Then we see Q0 and Q3. So Q0 and Q3 both are non-final, so they are indistinguishable. So you might ask me, like, why are we not doing it as 0? We are not doing it as 0 because if we go through each and every row like this, maybe sometime or the other they can be distinguishable. So you will understand that when I go through each and every row. Now Q0 and Q3 are both are non-final, so we are not marking anything. Now Q0 and Q4 again final and non-final, so we are marking it as 1. Now Q1, Q2 again non-final, final, so we mark it as 1. Q1 and Q3 both are non-final, so we don't do anything. And then Q1, Q4 again they are distinguishable, so we mark it as 1. Now Q2, Q3 again they are non-final and final, so we mark it as 1. Q2 and Q4 both are final, so they are indistinguishable, so we don't do anything. Now Q3, Q4 again non-final and final, so we mark it as 1. Now we did all the distinguishable states. Now let's come back to the indistinguishable states. So to do that, to fill the other boxes, to fill the indistinguishable states, what we do is we check Q0 and Q1, but from this table. So we try to see that the Q0 and Q1 on input A, where are they going to? They're going to Q1 and Q3. So what we see is we try to see Q1 and then Q3. So we are trying to see this box. So this box has nothing in it. So we don't do anything. So we just leave it like that. So in the same way, we're going to check Q0 and then Q3 now. So Q0, Q3 on A goes to Q1, Q3. Is there anything in Q1, Q3? Nothing. We also need to check on the B input. So for example, Q0, Q1 on B. So Q0, Q1 on B goes to Q2, Q4. So what is in Q2, Q4? Q2, Q4 is also empty. So we don't do anything. Now Q1, Q3 on B. So Q1, Q3 on B goes to Q4, Q4. So Q4, Q4 is 0 and we can't do anything because it's a self loop. So in the first iteration, the Q0 had nothing. So we didn't mark any of the boxes. Now let's come to Q1 and Q3. We are trying to fill this box. So Q1 and Q3. Now let's see Q1, Q3 on input A. So it goes to Q3 and Q3. It's a self loop, so we can't do anything. Now this box is also not filled in the first iteration. Now let's come to the third row, which is Q2. And the only box that is left is Q2, Q4. So let's try to see Q2, Q4 on input A. So Q2, Q4 on input A goes to Q2, Q4. So we don't do anything. Then Q2, Q4 on input B goes to Q4 and Q4. So Q4, Q4 is self loop. So we don't do anything. So even in the first iteration, even for Q2, there is no match at all. So once this is done, we'll again go back to this thing for a second iteration. But if you observe, even if it's a second iteration or a third iteration or any number of iterations, you can't actually proceed from this. So you are stuck at this. So if you're stuck at something like this, you just mark all the empty boxes as 0. So this is how we fill the table. So this is basically a simple question. That's why we are not able to like change, like we are not doing ones or zeros. But in other questions, in a few iterations, like after one iteration or second iteration, these values get changed. Sometimes you can get a distinguishable thing, or sometimes you can get a indistinguishable thing. So in the end, if after any number of iterations, if it's the same states, and if it's the value is not changing at all, then we just mark it as 0. So this is how we fill the boxes. So after we fill the boxes, we try to see the boxes which has 0. We try to see the combinations. So here q0, q1 has a combination of 0. So these two are indistinguishable states. Then q0, q3 again indistinguishable. Now q1, q3 is also indistinguishable. q2, q4 is also indistinguishable. And q3, nothing, we don't have anything, and q4 also we don't have anything. So we never, so if we do it in the upper half, we don't need to do it on the lower half, because it's the same way. So even if you do it like on the lower half or the upper half, anything is the same. So we don't have to do anything for this. So as you can see, q0, q1 is one state, and then q0, q3 is one state, q1, q3 is one state, q2, q4 is one state. So here we can see that some things are correlated. So q0, q1, and then q1, q3, q0, q3, q2, q4. So something is similar between these states. So we try to merge the states together. So if we merge, we can see that q0, q1, and then q0, q3, q0, sorry, it's just q1, q3, and then q2, q4. So if you see, there is a correlation. There is a correlation between these three. If there was a connection between q3, q2, and if there was a connection between q1 or q2 and then q2, q4, we would have merged everything. But here we are only merging these things, q1 and q3 into one state and q2, q4 into one state. So if we do a DFA for this merged states, so we can see that q0, q1, q3 in one state and q2, q4 on in one state. So how do we do this inputs again? So it's same. It's we see this transition table. So we just go through this transition table one by one. So q0 on A goes to q1. So we are doing q0 on A goes to q1. So similarly, we are just putting the inputs like this. So we are seeing, can you see that these q2, q4 as the final states? Because our final states in the question are given as q2 and q4. So we marked these two as the final state. So for example, if q1 is also a final state, then you mark even this as the final state. But here in this DFA, only q2, q4 are final states. So we just denote them as final states. So this is how you convert a big DFA to a minimized DFA by merging similar states together. So similarity can be found by distinguishability or indistinguishability. So sometimes they may give you questions like, can you minimize an NFA? So we can't minimize an NFA directly. So we need to convert the NFA into its equivalent DFA, and then that DFA can be minimized using this algorithm. Hope you like the video. Hope you understood the topic. Thanks for watching. Bye.